too. Like, it was just so much effort.
Do you think you're gonna want to do that effort after you go to?
Oh yeah, I mean 4 years from now, I don't know. That's
Future
a
Bailey
4 years.
Yeah, exactly. That's
Future
not,
Bailey.
that's a future Bailey.
Maybe 4 years to work on that.
Yeah, exactly.
All right.
I'll have it so ready.
All right. So yesterday we talked about radians and degrees. Any questions about that? Totally review. We're good. Okay. So today we're going to talk about quadrantal angles.
That's a word. That's right there.
So quadrantal angles, these are just angles that are a multiple of 90 degrees. Okay? That's a quadrantal angle. Any angle which is multiple of 90 degrees. Or pi over 2. Okay? So, like, for example, negative 270 is a quadrantal angle. As is 3 pi over 2. Or negative 8 pi. Or whatever. These are all examples of quadrantal angles. They're called quadrantal angles because if you were to graph them in standard form, like negative 270 ends up right on the border of quadrant 1 and 2. 3 pi over 2, if you were to graph it, ends up right on the border of quadrant 3 and 4. Negative 8 pi, if you were to graph that, that's 4 complete rotations. It ends up right on the border of quadrant 1 and 4. Okay, that's why they're called quadrantal angles. Okay? So we're going to focus on trig values of quadrantal angles. So before we do that, there's an important concept to understand. And here it is. That any point on unit circle has coordinates cosine theta, sine theta. Okay, so unit circle is a circle of radius 1 centered at the origin. It's like this, where the radius equals 1. So if we have a point on the unit circle, like this point right here, generally, let's just say it has coordinates x, y. Right? If it has coordinates x, y, I know this distance is 1 because that's the radius of the circle. This bottom length right here is x, and this side length is y. So if this is the angle theta right here, that's theta. I could just do trig to it, right? I could say like the sine of that angle is opposite over hypotenuse, y over 1. Well, this is saying y is the sine of theta. And the cosine of that same angle is x over 1, adjacent over hypotenuse. So x equals cosine theta. So any point on the unit circle has the coordinates cosine theta, sine theta. Now, I happen to draw a point that's in the first quadrant, but the fact can be generalized for any point that's on the unit circle. Okay? So if you're trying to find trig values of any quadrantal angle, that's nice and convenient when it comes to the unit circle because points on the unit circle that are between quadrants have nice coordinates. 1, 0, and -1, right? So if I have a circle like this, I know the coordinates of these intersection points. Like this point has coordinates 1, 0. This point has coordinates 0, 1. This point has coordinates -1, 0. This point is 0, -1. So if I wanted to find, for example, the sine of 90 degrees, I could just go to 90 degrees, and I know that this point right here actually has coordinates cosine 90 degrees, sine 90 degrees. So sine 90 degrees has to be 1. The answer is 1. If they ask us to find cosine of 90 degrees, it's 0. The x value. By the way, a lot of people get confused about, they'll think it goes sine and cosine because that's the order in SOHCAHTOA or something. But it goes cosine, sine. I just remember it's like alphabetical order. That's kind of the way I remember it. Cosine is the x value, the sine is the y value. It's a really common mistake for people to just mix them up, okay? If you wanted to find the tangent value, then you just have to use the fact that the tangent is actually sine over cosine. So remember, the tangent of any angle is the sine of that angle divided by cosine of that angle. And that's obvious if you just think about SOHCAHTOA. The tangent is opposite over adjacent, right? The sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. If you simplify the right-hand side here, you really just take the top fraction divided by, or times the reciprocal of the bottom fraction. This is opposite over hypotenuse times hypotenuse over adjacent. And you can see exactly the h's cancel and you get O over A, opposite over adjacent. So that's why the tangent of any angle equals the sine over the cosine of that same angle. So if I wanted to find, in this case, the tangent of 90 degrees, it's going to be sine over cosine, 1 over 0, which we know is undefined. Whenever you divide by 0, it's undefined. So that would be the answer here, undefined. Okay, that's all there is to it. So if I have something like, if they ask me to find the cosine of -3 pi, I would just picture this angle graph. Remember, 2 pi is a complete rotation. So 3 pi would be 1.5 rotations. So here's a unit circle. This is going to be 1.5 rotations backwards, but it really doesn't matter, right? But I'm going to go clockwise since it's a negative angle. So -2 pi, and then another pi more would be there. This point I know has coordinates -1, 0, and it goes cosine, sine. So the answer is -1. This is totally reviewed, right? One more example, what if it was something like tangent of, let's say, 2 pi. Tangent of 2 pi. 2 pi is 1 complete rotation. This point has coordinates 1, 0. And this is sine 2 pi over cosine 2 pi. So it's 0 over 1. If the numerator of a fraction is 0, it's 0. If the denominator of a fraction is 0, that's when it's undefined. So this is just 0. Okay. So that's one way to calculate trig values of quadrantal angles. The way I actually do it in my brain is a little different, so I'm just going to show you it in case you like it better. Okay? This way works perfectly. You're welcome to do it this way. I think the other way, for me, it's a little quicker. So here's the way I think of it. Like, I just picture the graphs of sine. I know sine looks like this, and it's totally symmetric, right? So that's like 90, 180, 270, 360. And then sine looks like this. And it's totally symmetric. So that's 90, 180, 270, 360. So if I had to calculate, for example, the sine of 270, I can just picture the graph. I know that at 270, it's at its lowest point. So this would be -1. And that's the way I picture it and do it in my brain. If I wanted to find like the cosine of -90 degrees, this graph continues, and at -90, it's right there. This is going to be 0. If I wanted to calculate the tangent of pi, that's the tangent of 180. It's just going to be sine over cosine. So it's going to correspond to 0 over -1. 0. So that's the way I do it in my head, partly because that's the way I was taught, and partly because it feels quicker to me, but maybe that's because that's the way I was taught. I don't really know. If you like the unit circle way, you can definitely do it that way. If you like this way, try it this way. Okay? Any questions? This is fully review, I hope. Does everybody remember doing this? Good. Hopefully you feel that way the whole unit. That would be good. That's all I got. So the homework tonight is called unit circle and quadrantal angles. That's what it's called. Unit circle and quadrantal angles. And I think it's pretty short. But I know